and the last thing we have to talk about in lesson 2.3, and this is what I deemed part 2, is positive and negative intervals on a graph. So where is the equation positive? And so when I talk about positive, we're talking about on a graph, where is it above the x-axis? And where is a graph negative? So on a graph, where is it below the x-axis? Where does it have positive and negative values? Now, in order to do this, what we need to look at is the different intervals. Okay? So we need to, what we're going to spend our time doing here is we're going to figure out where does our graph cross the x-axis, and then in which sections is it positive and which sections is it negative. Okay? So, in this particular question, it is phrased as identify the interval or intervals in which the function y equals x squared minus 2x minus 3 is positive. Now, when we talk positive, where is positive going to be on a graph? That's going to be wherever the graph is above the x-axis, right? Now, here's the deal. Well, yes, you can graph this on Desmos to help check yourself. That's not something you're going to have access to during a test. So it's how do we figure this out algebraically. Okay? So, with that in mind, how do we figure out where a graph crosses the x-axis? How do we figure that out? Solve for x. And what were we doing in the first part of this lesson to solve for x? Taking the equation.
Factoring it.
Okay, did we do a whole bunch of factoring?
Yeah,
we did a whole bunch. Nope, you're right. I want to hear factoring. We did a whole bunch of factoring. We set the equation, those factors equal to 0, and those were our zeros, or our x-intercepts. Okay, so that's what we're going to start again with, is we're going to take this equation and set it equal to 0. So I'm going to kind of, as we go through on this first example, I'm going to kind of write some notes here that you can go back and look at to help, explain what we're doing. But the first thing we're going to do is we're going to factor define the zeros, where the graph changes. Okay, so this is kind of step 1. Factor to find zeros. Okay, and when I say find zeros, where the graph crosses the x-axis and turns from positive to negative or vice versa. Okay, so I guess after zeros I can put x-intercepts, and that's going to be where the graph turns from positive to negative and vice versa. You can handle it. Or don't write it down, just write the example down. I wrote something down. Okay? The key is we're going to factor. Okay, that's like step 1, is we're going to factor. The whole point of factoring is that's going to tell us where our graph is going to change from positive to negative. So, in order to factor this, we're going to start by taking the equation and setting it equal to 0. So, x squared minus 2x minus 3 equals 0. What do you know? No, because we're setting the equation equal to 0. Because that's going to help us find our x-intercepts when y equals 0.
You have a sum of 3 maybe, or 2. I don't know that many.
Well, I always start with product, so that's why you're throwing me off. But okay, so if we're going to talk sum, we need a sum of the negative 2, and then a product of the negative 3. Okay, whichever way you want to think about that. So we need numbers that multiply to be that c value of negative 3, and they add to be negative 2. Well, okay, folks, this is an easy one. The only numbers that multiply to be 3 are 1 and 3. 3 and 1, right? So it's some combination of that. How do two numbers multiply to be a negative? One positive, one negative. How do they add to be negative? Bigger one's negative, smaller one's positive, yes? So, now what do we do with that 1 and negative 3?
You split them x's.
Okay. Because this is just a 1x squared, we're going to set up the two parentheses, right? X squared breaks into, I say x and x, you guys say two x's. One parenthesis is the plus 1, the other parenthesis is the minus 3. Doesn't matter which parenthesis is which. And now officially what do we do? Yeah, set each factor equal to 0. X plus 1 equals 0. X minus 3 equals 0. We get zeros of negative 1 and 3. Are you guys with me there?
Yep.
Now, what's that? What are those numbers? Those numbers are my x-intercepts, yes? So I'm going to set up a number line, trying to figure out where I want to do it because I got lots of stuff to write here. I'm going to set up a number line. Probably didn't need to be that long, but that's all right. And I don't really care about the spacing other than I want my numbers in order from left to right. So I'm going to put negative 1 first, and I'm going to put 3 secondly. I'm not worried about all the numbers in between them. I'm only worried about those two numbers, okay, because those are my zeros. Those are the places where the graph crosses the x-axis. Okay? Now, we had 2 zeros. How many intervals did I end up with? Two zeros created how many spaces? 3? 3, I hope? There's a space to the left of negative 1, yes. There's a space in between negative 1 and 3. That's what I meant. And then a space to the right of 3. So in each of those spaces, my graph is either going to be positive and above the x-axis or negative and below the x-axis. Okay, so 2 zeros create 3 intervals. More zeros create more intervals, right? Okay. I want to know, over here to the left of negative 1, is my graph above the x-axis or below the x-axis? And you say that because you are guessing or because you have a reason?
Well, I just think it's negative. I don't know.
Now this number is negative 1. But see what's happening is my graph is crossing at negative 1 and 3. I want to know, is it above or below here? Okay. And
It's
so,
above,
why?
because it's coming.
Yeah.
Okay. Could you look at what this graph is and the shape of it and think about it that way?
It says positive.
Okay. You can to an extent. Okay. Now, here's how I want to verify, because here's the deal. Do we always know the shape of the graph?
No.
No. This is a parabola. I'm with you. We know what a parabola looks like. Okay, but we don't always know that. So I'm going to suggest we pick a value to test. What is a number to the left of negative 1?
Negative 2, 3.
Are they both true answers?
Yes. Yeah.
Okay, now, I'll be honest. I'm going to go with negative 2. Is he going to be all right if he uses negative 3?
No.
He is. Okay, so I'm going to say that we're going to test x equals negative 2. And so what we're doing here is we're going to pick test values in each interval. And I'm going to write that down as kind of my last step here. Is that we're going to pick test values in each interval.
You're going to write that down when you're writing down.
That's up to you. It's just kind of steps. If you don't feel you need it, then don't write it down. Okay. Okay. Now when I say test x equals -2, where can I plug -2 in?
Wherever there's an extra
Negative.
problem.
Yeah. In the original problem, yes. So we can plug it in here. So if I plug in -2, it's x squared. So -2 squared minus 2x, so minus 2 times -2 minus 3. Right? Okay, so that's what we're using right there. Do some math with me. -2 squared is 4. Minus 2 times -2 is going to be plus 4 minus 3. 4 plus 4 is 8, minus 3 is 5. Okay, guys. What do you know about the number 5?
Positive.
It's awesome.
Okay. 5 is positive. Okay. 5 is positive is what I was looking to hear. And since 5 is positive, that represents that whole interval. Okay. My graph, the first time I crossed the graph, or the x-axis at -1. Over here, it never crosses. So I use -2. I get a positive number. I know this section of the graph is going to be positive, which means this section of the graph is going to be above the x-axis. Braden could have used his -3. He wouldn't have gotten 5, but he would have gotten a positive value. Could we use -10?
Yeah.
Sure. You're not going to get this exact number, but you're going to get a positive. That's all I care about is what kind of, are you going to get a positive or negative value? Okay? Now, you can guess what's going to happen here, but I want us testing because this is a process I want us to learn here. So what's a number between -1 and 3 you want to use to test?
2.
I like 2, but I'm not going to use it. 0 is the easiest number to plug in. Now, okay, I heard 0, I heard 1, and I heard 2. Are those all good numbers? And if someone really wants to get fancy, could they use 1.5?
Ew.
Exactly. Ooh, but could use it.
Sure.
Okay. I'm picking 0 just because it makes my life easier. It makes my math easier. So now where am I plugging 0 into?
X.
The x squared minus 2x minus 3. So 0 squared minus 2 times 0 minus 3. Well, what do we know?
I don't want to see that. Can't see that.
0 minus 0 minus 3 is -3. What do you know about the number -3? It's negative. Good. You're stating the obvious. That's what I want. Now, if that response, that y value comes out to be negative, what's that represent about this whole section? This whole interval is going to be negative, meaning it's going to be below the x-axis. Okay? And then, again, you can kind of guess what's going to happen here, but I want you to understand the process. I want you to make sure it works. Pick a number in the final interval. What can you test to the right of 3? 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever you want.
32.
Okay?
No.
More power to you. I'm going with 4. Okay? So, what am I doing with 4? Yep, putting it in for x. Good. 4 squared minus 2 times 4 minus 3. 4 squared is 16. 2 times 4 is 8. So I have 16 minus 8 minus 3. 16 minus 8 is 8. 8 minus 3 is 5. What do you know about the number 5? It is positive indeed. So what do we know about the whole section to the right of 3? It's positive. Okay. So my question here was asking, identify the intervals on which the function is positive. Okay, and again, when we say positive, we can talk about where is it above the x-axis, because that is what I'm asking here. Now, I just need to state those answers. When is it positive?
At 5.
Between negative one.
At 5. No, -2. -2 and 4. Wait, what?
Okay.
I don't know.
Left
Okay.
is negative 9.
Okay. That'll get me started.
Right?
It's positive to the left of -1
And to the right.
and to the right of 3. How do we express this in mathematical correctness here?
No. It's
I give up.
Those values are what? To the left of -1. How do you express the left of -1?
You're greater.
If they're to the left of -1?
Less than negative.
Okay.
Someone's right.
So one option, x is less than -1,
Or
or what's this other option?
greater than 3.
Greater than 3. Okay.
You have to put that they're both at 5.
It doesn't matter because not everyone's going to get 5. If you plugged in a different number in that same interval, you won't get 5. And they won't necessarily always come out to be the same. It's just the way it worked here. With this in mind, okay, 50-50 shot. What's Savas going to want? They could want inequalities, or they could want interval notation. I don't remember. Of course I don't remember. So, but while we're here, x less than -1, how do you write that interval notation? Where does that interval begin?
Negative.
Negative infinity up to -1. So that's negative infinity to -1. Infinities always use parentheses. And -1 would use a parenthesis here also, because at -1 it's 0. Okay, we just want to know where it's positive. And then over here, x greater than 3. Well, that's going to be, or x greater than 3, that's going to be from 3 to positive infinity. Infinities use parentheses, and the 3 is going to use a parenthesis. Okay? I have the interval notation circled on my paper. However, could Savas want inequalities? They could. They kind of bounce back and forth, don't they? Okay. My goal for you guys is to be able to work with either. That's my goal. I want you to be comfortable with either. Okay. Questions on this one? Okay. You ready to try the next one?
Yeah.
Okay. Now, I'm not going to rewrite all these notes to the left, so you'll be happy there. I'm not going to make you write words in math class as much this time. You guys act like it's horrible. Okay. Next problem. This time it's identified the intervals on which the function is negative. So what are we talking about with negative? We're looking for where the graph is what? Below the x-axis. Good. What am I going to start off doing? Look at your previous example. Setting that function equal to 0. So x squared minus 4x minus 21 equals 0. Are we pros at this part? Okay. Product of -21, sum of -4. Well, besides 1 times 21, I've only got one option in my brain. 7 times 3 is 21. And that's the pair it's going to have to work, isn't it? So 3 times 7. 7's going to be negative. Okay. If it multiplies to be a negative, you need one positive, one negative. If it adds to be negative, larger number negative. Now, are those my answers? Should I go straight to my number line?
No.
No, those go in my factors. So this is 1x squared again. So x squared breaks into the two x's. And then you have a plus 3 and a minus 7. We're going to take those two factors and, good, set them each equal to 0. X plus 3 equals 0. X minus 7 equals 0. You solve those and you get x equals negative 3, x equals positive 7. Okay, so you have to do that part, yes? Now, negative 3 and 7, what are those? X-intercepts, is that what you said? Yeah. These are my x-intercepts. Sorry, I wrote words. I guess I lied. X-intercepts or zeros. So just kind of a reminder there. So if they're my x-intercepts or zeros, that means they're going to be on the number line here on the graph. Negative 3 comes before 7. So I'm putting negative 3 on the left, 7 on the right. And what do I do? Pick some values we want to test. What are we picking to the left of negative 3? Can't use negative 2. I can go with negative 4. This is why we talk about it. Get those careless mistakes out today, right? Or right now, right? So you're not getting them out later. So we're going to test negative 4, which means negative 4 quantity squared minus 4 times negative 4 minus 21. I'm plugging into this equation up here, right? Negative 4 squared is 16. And don't let your calculator trick you into thinking it's negative 16. When you square a negative, it's always going to become a positive. Minus 4 times minus 4 is plus 16. And then minus 21. 16 plus 16 is 32. Minus 21. I think it's 11. In all honesty, here's what I know. 32 minus 21 is a positive. Do I even really have to know the number? Not in my opinion, you don't, because I just know that 11 is positive. Okay? So what do I know about that section? It's positive. Okay? Now, you can take a guess about the next one. I'm just going to keep testing because I want us to have this practice. What's a good number between negative 3 and 7? I would go with testing x equals 0. Makes the math easy. 0 squared minus 4 times 0 minus 21. 0 minus 21 is negative 21. Were you expecting that to be negative? Yeah, you were. Or you should have been, I guess I should say. So there's negative. How do you test the section to the right of 7?
8.
Either or. I'm just going to stick with my process of using x equals 8. 8 squared minus 4 times 8 minus 21. 10 actually wouldn't have been bad on this one, would it? 10 would have actually probably been better. 8 squared is 64 minus 32 minus 21. 64 minus 32 is 32. 32 minus 21 is 11. And 11 again we know is positive. So this is a positive interval. What's my answer? What's the question asking me?
Negative.
This time it's when is the graph negative? When is my graph negative this time?
Less than 7.
Okay. Less than 7, greater than -3, between -3 and 7. Okay. So, if you say less than 7, greater than -3, when it's between two numbers, remember your best bet is to take the x and put it between the two numbers. You remember this? That's going to be your best bet because they're not going to want it in two statements when this value is between. So this is x is less than 7. And then officially it's greater than -3, but this pieces are flip-flopped. So instead of saying x is greater than -3, it's -3 is less than x. Or, I think interval notation is easier on this one. I just don't remember what they're going to give you in homework. Interval notation is the shading just goes from what? Would start at -3, and the interval ends at 7. We're going to use parentheses. Both are perfectly fine for me. When you do something like this on paper for me, they're both good answers. Unless I say in the directions, give me your answer in interval notation or inequality, I'll take it either way. Okay. Now, this one, the difference was it was still a right side up parabola. So the parabola still was positive, went down here, was negative, and then went back up positive. Okay. I have parabolas in the homework questions or in these questions, so that's what we're getting as examples. Keep in mind, it won't always be that way, and I want you to know this process. Okay, one more example. And what's different about this last example?
We're not asking.
We're gonna have to FOIL or whatever it's called. Like the P product of AC.
Okay. So two things. One, this isn't asking where is it positive or where is it negative. It's giving me an inequality, right? So we're going to have to figure out what are they wanting. Basically, we're going to have to talk, okay, greater than, less than, are they asking for positive or negative? But then also looking ahead, are we going to have to work a little harder on the factoring here? We are, okay? So first things first. We have to know what they're asking. So we have to we have to be able to factor. So we need to get this inequality so it has 0 on one side. I would say equal to 0, but it's not going to be equal to 0. So how can we get this so that the 0 is on one side?
Subtract the 3x plus subtract the 3x and yeah.
How about I subtract the 3x and subtract the 8?
Yeah.
Is that where we're going with
I
that?
knew what I was trying to say, but I
Okay.
can't say it.
So when I subtract the 3x and subtract the 8, I'm now going to have the inequality 5x squared minus 3x minus 8 is something 0. What is that sign? Bigger piece comes first.
Less than. Greater than.
Greater than. Okay? This is our greater than sign. Now, is that going to be necessary to get this problem right?
Yes.
Yeah, it is. Okay? So you have to place that this is asking for greater than 0. And when the graph is greater than 0, positive or negative? Positive. So we want to know, when is this graph positive? Okay? Now, at this point, we need to solve the related equation. So I'm going to drop the greater than sign and just worry about the equal sign. 5x squared minus 3x minus 8 equals 0. And how are we doing with our factoring?
Great.
Do we know how to factor?
Product is -8.
What'd you say?
So product is
Not just product of -8.
You have to flip this.
Okay, so either way, it's going to be a product of negative.
3, 8, 5. Zero at this point.
It's the number that's not on the screen yet because we haven't shown it yet, but okay, there's a 5 out here, yes? Is that going to make this problem a little more challenging?
Yes.
It is. Your options are either slip and slide or product of AC. Okay, I think my majority of you are preferring slip and slide right now. Okay, so if we slip and slide, now don't let me forget to undo the slip and slide at the end because that's my issue. I don't know. So we're going to take this 5 and slide it over, right? So x squared minus 3x minus 40. 5 times 8 is 40. So now I need a product of negative 40, a sum of negative 3. What do you know?
8 and
8 and 5?
Yeah.
Somewhere there's a negative in there. Okay. Because it multiplies to be negative 40, you need a negative. Because it adds to be negative 3, bigger number negative. So x squared is x and x. We have a plus 5 and a minus 8. Now, what's the catch?
You already got equals to 0.
We have to take that 5 back out, don't we? Okay. X plus 5 over 5. X plus 1. X minus 8 over 5?
5x minus 8.
Yeah, officially that 5 goes back out front, and it's 5x minus 8. Unless you're someone that in this scenario, what's our next step? Our next step is to set them equal to 0, right? So could you leave it x minus 8/5 equals 0 in this scenario? Because we're solving, yes. If you need the factors, no. But, okay, so we set each factor equal to 0. If it's x plus 1, we're going to have x equals negative 1. If it's 5x minus 8, what's going on here? 5x equals 8, so x is 8/5. Okay. What is this negative 1 and this 8/5? X-intercepts, right? These are the zeros, the x-intercepts. Good. Okay, so we're going to take those x-intercepts and put them on the number line. All I care about is which one goes to the left and which one goes to the right. I don't care about any numbers in between them. So I have negative 1. I have 8/5. Okay. Okay. So left of negative 1, she says negative 2 would be a good value to test. I could go with that. Test x equals negative 2. Now, where are we plugging that into?
Is it the one we already do the 5 under that?
We're going to use when it's all on one side. Okay? So whichever way, I'm going to grab this piece. We're using that. The 5x squared minus 3x minus 8. So 5 times negative 2 squared minus 3 times negative 2 minus 8. Do some math with me. Negative 2 squared is 4 times 5 is 20. Minus 3 times minus 2 is going to be plus 6 and minus 8. Well, I'll be honest, without doing the math, I know what this is going to result in. Because I know 20 plus 6 and subtract 8, I'm still going to be in positive land. But 20 plus 6 is 26. Minus 8 is 18. And all I need to know about 18 is that it is positive. Okay, so this segment is positive. What about between -1 and 8/5? Between a negative and a positive, 0 sounds excellent, doesn't it? 5 times 0 squared minus 3 times 0 minus 8.
-8.
0, 0, and minus 8. So -8, which is negative. So this is a negative interval. Now, what about to the right of 8/5?
2.
Could we use 2?
1.
9,
Why would you?
2,
Wait.
Okay, here's the deal. It just has to be bigger than 8/5, yes?
1.
What is 8/5?
It's like 1 and 3/5.
Okay, so 8/5 is 1 and 3/5, which is 1 and 3/5 or 1 and 6/10, 1.6.
No, like whatever happened with decimals. This is with decimals.
Here's the thing. Can you have a calculator by your side? Can you go decimals? Yeah. So, what's the smallest whole number we're going to use? 2. Okay, so you should actually like Braden's this time, because he didn't pick an extra big one, did he? He picked the first number you can use. Could you use 37?
No.
Yes.
He could.
Do
I'm not.
Use 37 and see what you get right now.
Okay, so 5 times 2 squared minus 3 times 2 minus 8. 2 squared is 4 times 5 is 20. Minus 6 times 2 minus 8. Again, we end up at not 18.
Nope.
Oh, it's not going to be the same number because we're not the same distance over. That's why.
6.
So, yeah, 20 minus 6 minus 8 is going to be 6.
Positive 6.
And ultimately, all that matters is 6 is positive. So this is a positive interval. Now, what was our question asking?
To solve. Oh,
Okay, yes, we had to solve.
Where is it positive at? In greater
But-
than 0.
We got here to where we were greater than 0. So we wanted to know positive. Where are we positive? On those two pieces out there, yes?
less than -1 or greater than 8.
Negative infinity, -1, 8 places. Are you okay?
Less than -1 or greater than 8/5. Or if you do interval notation, less than -1, it's going infinitely left, so negative infinity to -1. Or if you're going starting at 8/5 and going right, it's 8/5 to infinity. Okay, guys. You have a homework that goes with this. Okay, part 2. Due tomorrow. I finished my notes, due tomorrow. Okay?
Did you get